the Heck reaction as part of the advanced organic chemistry. So the general reaction for the Heck reaction involves coupling this R group to that species over there, and you can see that nothing happens to the alkene group, and all that really happens is that R group attaches to that end of the alkene. This is done through a palladium catalyst with the oxidation state of 0 in the presence of a base with an alkyl halide byproduct. The history of this reaction comes from Heck, 1972. The following conditions: you have your alkyl halide, you have your alkene. What you want to do is this carbon bonds to this carbon over there. In this reaction, you can see that they are trans to each other. With a 75% yield. The palladium catalyst is palladium with acetate ligands. The overall reaction occurs through a catalytic cycle, in that the palladium is used to attach the R groups to each other. So for instance, in this example, there's the one R group, and that is going to be attached to that alkene. So all these steps are going to be elucidated in the next slides. What is important though is that the ligand attached to the palladium over here is a triphenyl phosphine ligand, PH3. You don't need the brackets, but you can have them if you want. So this reaction occurs through various steps. So you can first have the ligands attached to the palladium, it's 2+. The alkyl halide group attaches with the alkyl halide being broken apart into two segments, the halogen on the one side and the R group on the other. So let's just call that R1. And this R1 group is going to attach to that carbon on the alkene. The double bond, the pi electrons, are going to come closer to the palladium. This will lead to a rearrangement, okay, in that this group here is going to bond to that carbon there, with the ligands being untouched. This hydrogen is going to be abstracted and dragged onto that palladium there. In this process, the alkene is formed, but it is bonded in the previous step through that carbon there. But you can now see this hydrogen has attached itself to that palladium. This is a hydride over here, and it can be used further on. The product that you want now will leave from the palladium because of this hydrogen over here. It's made the palladium stable, and it breaks off. You can see that you have that trans relationship again. What you form is a palladium bromide species, and the two ligands unattached, remember, a triphenylphosphane ligands, triphenylphosphine. Because that hydrogen and that bromine are still on the structure, that can come off so that we can reform our palladium catalyst, and then the cycle repeats as per catalytic cycle 2 or 1.